All right, guys, let's knock out this practice test. Test 12 review. Number 1 and 2 are law of cosine problems like we did on Tuesday. So if I were you on number 1, I just like to find the biggest angle first. So I'm gonna go with cosine of c equals would be c squared, which is 16 squared, minus a squared, minus b squared, all over negative 2ab. And don't forget, once you punch that in your calculator, that you got to hit inverse cosine. And when you do that, when I did all that work on my calculator, I got about, nearest degree, I got 93 degrees. I also need to find angle B and angle A. I'm going to go the next order, like largest to smallest. So I'm going to find cosine B next, or angle B next. So I'm going to go 12 squared, which is B squared, minus A squared minus C squared, all over negative 2AC. And again, at the very end here, I'm going to punch all that in, and I'm going inverse cosine to get my answer. I'm going to punch all that in and get my second cosine. I'm getting 48.5 degrees, so I'm going to round that to 49 degrees for angle B. And then real quick, to get my last angle, I'm going to subtract those two from 180 and getting 38 degrees. So there's your three angles for number 1. Let's go to 2. Number 2, they gave me a side this time. If you draw your triangle, that angle A, oh, look at this, actually, and I can't promise it's going to be this way tomorrow, but I'm looking at this, and I'm looking, hey, that's A and A. All right, so that means I can do law of sines, which is what I'm going to do. So I'm going to do sine 55 degrees over little a equals sine B, big B, over little b, which is 65. And again, I'm going to cross multiply. And again, after I cross multiply and divide, I'm going to go inverse sine to get my big B. And when I worked out my sine B, I got 1.0649, and that's bigger than 1. And if you hit inverse sine on your calculator, it's going to give you an error, which means this is no triangle. I don't know if I would expect that tomorrow. You could, like there may be a law of sines problem there. So be prepared either way, law of sines or law of cosines. All right, keep going. Number 3, find the area of the triangle with those side lengths. To find that area with side lengths, you got to find the semi-perimeter first. So I'm going to add up all the sides. 3 plus 5 is 8, plus 6 is 14. You take the 14 divided by 2. That's 7. There's your semi-perimeter. To find the area, you take the square root, you do the semi-perimeter, and then you do the semi-perimeter, which is 7 minus each side. 7 minus 3, 7 minus 5, 7 minus 6. And I'm just going to punch that in. I'm going square root of 7 times 4 times 2. I don't need the 1 really. Hit enter. I'm getting about 7.5. 7.48 is the area. I should put meters squared after that since they did say it was meters. All right. Number 4, 5, and 6 are really quick. Well, at least 2 of them are. Find the reference angle. If it's a pi over 2 or pi over 3 or pi over 4 or pi over 6, remember what the trick is, you can just drop the top. So number 4, the reference angle is just pi over 3. And number 5 is just pi over 4. Those are really quick. Now, number 6, you kind of got to figure out. Remember, reference angles means how far from the closest x-axis is it. Negative 5 pi over 8. Remember, the x-axis have the whole number of pi's. Like that's 0 pi, 1 pi, 2 pi. This over here is 3 pi if you keep going around. So that's really, if you go negative 5 pi over 8, you're going this way. Negative 5/8 to pi. So how far from the x-axis are you? You're negative 3 pi over 8. Because if you added the negative 5 and negative 3 pi over 8, it'd give you negative 8 pi over 8, which is negative 1 pi, which is on the x-axis. That's why it's negative 3 pi over 8. So again, 4, 5. If it's a pi over 3, pi over 4, pi over 6, you can just, or pi over 2, you can drop the top. Otherwise, you kind of got to figure out how far away from the next whole number you are. Number 7, find the terminal point. Okay, 5 pi over 4. Remember, unit circle, the reference angle. I'm just going to go this way. The reference angle will be pi over 4. And a pi over 4, the point is square root of 2 over 2. And also square root of 2 over 2. 5 pi over 4, 5/4 pi. That is in quadrant 3, which means they're both negative. That's all you got to do there. Number 8, the reference angle is pi over 6. So I'm at pi over 6, my x-coordinate is square root of 3 over 2 everywhere. My y-coordinate is 1/2 everywhere. Negative 11 pi over 6 would be like negative 1 5/6 pi, which would put me back in the first quadrant. Everything's positive, so that's my answer. And number 9, My reference angle is pi over 3. At pi over 3, I have a 1/2 for my x and a square root of 3 over 2 for my y. That's really the same thing as negative 2 and 1/3 pi is what that is. Negative 2 means you go all the way around the circle clockwise, you go in negative direction, and then 1/3 more pi puts you in quadrant 4. In quadrant 4, x is positive and y is negative, so you get a negative for your y coordinate there. I think that's all I got on this page. It is. All right. Number 10, show that that is on the unit circle. Now you got to prove this to me, so what I'm going to do is I'm going to do negative 7/25 squared plus negative 24/25 squared. You got to prove that equals 1, because if those two, when you square them, add them together equals 1, that means it's on the unit circle. So if I square the first one, I get 49 over 625. If I square the second one, I get 576 over 625. And you won't believe this, but if you add those together, you get 625 over 625, which is 1, which means it is on the unit circle. All right, number 11, now we're into the review. Find the length of an arc that subtends the central angle 50 degrees. That's this formula. Remember, theta is S over R, arc length over radius. But theta must be in radians. That's 50 degrees. So I'm going to go 50 divided by 180, reduce it. That gives me 5 pi over 18. That's my angle. The arc length is what I'm looking for. Don't know what that is. My radius is 3. So I'm going to cross multiply. 3 times 5 is 15 pi equals 18s, which is the arc length. So if I divide by 18, get 15 pi over 18, which reduces down to 5 pi over 6 meters, because it said radius is 3 meters. Number 12, find the average rate of change. A slope, y minus y over x minus x. My x's I know. I'm going to take the second x, which is 3 plus h, minus the first x, which is 3. To find my y's, you have to plug them in. So I'm going to plug in 3 plus h. Don't have a lot of room here. If I plug it in, let's go down here. If I plug it in, I'm getting this, negative 2 times 3 plus h squared. If you square 3 plus h, you get 9 plus 6h plus h squared. That's square, multiply double square. So I'm going to multiply all that by negative 2, and I'll get negative 18. I'm putting it up here. Minus 12h minus 2h squared. Now, my second x, I'm going to do minus, and I'm going to plug in the 3. If I just plug in 3 in there, 3 squared is 9. 9 times negative 2 is negative 18. So I'm going to get minus negative 18, which, by the way, is plus 18. So what's going to happen is my 18s cancel. I get negative 12h minus 2h squared all over just h on the bottom, because my 3's also cancel. Then I'm just going to divide the h into the numerator. It gives me negative 12 minus 2h. And guys, that's it right there. 13, suppose the graph of f is given. How would you obtain the graph from the graph of f of x? Okay, 13, the first thing I see there is a negative inside. That means it reflects across the y-axis. If the negative's in the front, that's a terrible across. That's supposed to say across right there. The y-axis, I don't have my pencil with me. And the minus 4 on the outside means it shift down 4. All right, number 14's got a negative in the front, so it reflects across the x-axis. Not sure what's happening to my thing. X-axis. Sorry about the handwriting. Looks like looking awful. Shifts left 7 because it's plus 7. Remember, inside's opposite of what you think. Number 15. 15, fraction equation, which means we're going to multiply by the LCD and get rid of the fractions. If you factor this, it's x plus 2, x minus 2. So another thing we need to do is tell what x cannot equal. X cannot equal either positive or negative 2. Don't forget that little fact. And that's my LCD, so I'm going to multiply every term by that. And what's going to happen, my fractions cancel. The first one, if I multiply by that, the x minus 2's would cancel. They will leave me an x times x plus 2. My second term, the x plus 2's would cancel, leave me 1 times x minus 2. And the 8, everything would cancel, so I just get 8. So over here, I'm going to distribute this x, and I have that 1, and I still have the 8 over there. So I'm going to move the 8 to the other side and combine some stuff. 2x and 1x is 3x. If I move that 8 over, it becomes minus 10. So I'm going to factor, that becomes x plus 5 and x minus 2. So my two answers are negative 5 and positive 2. But remember, it can't be positive or negative 2. So The 2 is extraneous. My solution is x equals -5. 16, simplify. Best advice here is find the LCD of the smaller fractions. Like if I look at my numerator, it's got a 1 over x and 1 over 2, which means my LCD would be 2x. So I'm going to multiply the whole top by 2x and the whole bottom by 2x. So my numerator, what's going to happen is if I do this one, the first one, the x's would cancel, so it'd just be 1 times 2. The second one, the 2's would cancel, it'd be 1 times x. On the bottom, I would have 2x times x minus. I'm not going to multiply that yet because what I noticed, the reason I didn't go ahead and distribute that is because I noticed I have a 2 minus x on the top already and an x minus 2 in my denominators. What I can do is I can cancel those because they're opposites. Remember, when you cancel opposites, you replace it with a -1. So my final answer here is -1 over 2x. And 17, graph this piecewise. So what I'm going to do first is I'm going to take, let me change colors here so you'll be able to see it. I'm going to plug the -1 in there. -1 plus 2 is 1. So if I plug in -1, I get 1. It's going to be a filled-in circle. And because it says less than, I'm going to go to the left. So I'm going to plug in -2 next. If I plug in -2 in there, that gives me 0. So -2, 0 is right here. I'm going to connect those dots, la, la, la. And I get that part of the line right there. Now the same thing with the second part. Take the -1. This is a parabola though. Remember, x squared is a parabola. So I'm going to take the -1, plug it in. -1 squared is +1. That point's already on there. I'm trying to make it darker, but I'm not doing a good job. I guess I could change colors. Maybe that would help. Or realize it's really just one graph. So that point's right there. It's going to the right. So I'm gonna do 2 or 3 points to the right. So I'm gonna plug in 0 next. 0 squared is 0. Plug in +1. 1 squared is 1. I'm gonna plug in one more. If I plug in +2, 2 squared is 4, which is right there. So the parabola is gonna look like this. It's gonna keep on going. All right, so there's your piecewise. One more slide here. And it's got one whole problem on it. Okay, so it says rationalize the denominator. That's pretty terrible. 5 minus the square root of 3 over 3 minus the square root of 3. You got to multiply by the conjugate. The conjugate of 3 minus the square root of 3 is 3 plus the square root of 3. So my denominator, those are conjugates, so I'm just doing foo. 3 times 3 is 9. If you multiply square root of 3 times square root of 3, you get 3. 9 minus 3. I'm going to end up with 6 down here. My numerator, I'm doing FOIL. I'm going first, outer, inner, last. So I get 12 plus 2 on 3. Because I have, that's a 2 of square root of 3, by the way. Because I have a 12, a 2, and a 6 and all even, I can take a 2 out of all those numbers. 2 goes into 12 6 times, 2 goes into 2 1 time, and 2 goes into 6 3 times, and there you have it, right there. All right, hope that helps. Use as much as you need. Hope you make 100 tomorrow. Really do. Cheering for you, and I'll see you then.